So, are we enjoying Unreal Fest so far? Oh, good. That's so much better than the last presentation I did. I had one person say, yeah. It's not good. So, today I'm going to be talking about embracing the Unreal way, right? So this was a presentation originally made by Zach Parrish, who I'm sure you all know, pink hair, tall, awesome. But today it's being done by me. So my name is Aaron Langmead. I'm a developer relations technical artist for Epic Games, with officially the longest title inside the Unreal ecosystem. But basically my job is to do licensee support in the tech art area and just generally try and get things more performant. So today I'm going to be talking about several things, but mainly it's just about getting you aware and understanding how we do things and how we recommend people do things. Both myself, Zach, all the people who do developer relations, and also the evangelists as well have seen just a huge number of game projects over the years. And we found some general trends, so it's a good idea to try and avoid some of these things, or do some of them. So I won't go through this list because we're about to run through it anyway. Let's just kick off. The first one, doing too much, which I used to be a lecturer, and I feel like I gave this enough times to my students, but we still see it as a common thing for developers, just generally anyway. So Unreal is just awesome, right? It's absolutely incredible, and every single year you see these amazing projects, these amazing tech examples. Getting a lot of echo here. We have these amazing projects that you see from not just us, but also the community at large. And the problem is with that is that we're game developers, right? So we're basically just hacky, cheating, I can't swear. And because of that, we end up seeing these things and going, oh, okay, well, you know, they've managed to make it look at this level of fidelity with this massive scale, with all of these things. That means it must be doable, so we can work at that scale as well. Not realizing that actually, in many instances, these things have been tricked and hacked and work a lot of the time in only certain use cases. So actually, when you're working and trying to figure out what your project is, you know, you have to take into account the fact that you're going to need to take on those tricks as well, or work on a different solution. So one of the big things that we see happening very early on is the amount of stuff that gets put into a scene. Often you'll have level designers and artists, and I've been very much guilty of this, just wanting to make it look as good as they possibly can. And the end result of that is often just a huge number of assets and a huge amount of stuff that's being put into the scene, both real-time and static. And then the other problem that we have with that as well is that people will then go, well, how much is too much, that kind of thing. And you end up with a very how long is a piece of string question. So why does this happen? We tend to find that there's very much, you know, kind of chaos of production. We have general platform changes. The amount of studios that I've visited already where, you know, we'll go, are you doing consoles? And they go, yes, we're doing consoles. And you go, Switch as well? And they go, we'd like to do Switch. That would be good. And at that point, you know, you're having to take into account a whole range of other things if you're deciding to go down that road. There's also misunderstanding how Unreal is built as a system in general. Often if you've come from one particular engine over to another, you can have a lot of issues with the tools coming in there. And then the biggest one that I think is a lack of ownership on all of these things. And we'll go into a little bit more of that in a bit. So, piece of string, right? How many is too many? And this is a very difficult thing to answer because it's very, very dependent on the game that you're building and can change drastically depending on the kind of assets that you're trying to build. So if you're creating a scene that needs to have 2,000 AI characters moving around your environment, there's going to be some implications to that, and that's going to have kind of cut-offs at other areas. You're going to have to scale down some other areas in order to reach that area. So it's very difficult to say. That being said, we generally say around 2,000 to 3,000 after culling. So that's in your scene at once. But the main thing is to test and test early. Another good way of managing this is understanding all of the reduction techniques that we actually have inside the engine. These are being added to all of the time. We've got new skeletal LOD tools that have been added. We've got budgeting systems. So learning to use those tools is often really, really helpful in actually building a more optimized and final end product. So the HLOD system is absolutely incredible. It allows you to just batch groups of objects based on a volume or based on a specific space. And it will take all of those assets and all of those materials, and it just makes it just one, right? One asset. And then you can dither out of that. And what's really, really cool is that you can then take that single unified asset that you've created, and you can build LODs based on that. So you can really control the distance at which you're controlling these things. Hierarchical instant static meshes are also useful. What people find really, really handy is building blueprintable tools that allow you to create instance meshes along the geometry. So you're not just using the foliage tool to paint down the instance meshes that you want. You can also create blueprints that spawn meshes within a volume, within a space, within along a line or a spline or a shape. And that can be really useful in creating a more controlled kind of instanced mesh actors. And of course, now as of 4.22, we have auto-instancing, which is absolutely amazing. We'll take basically your entire scene and just figure out what needs to be instanced and what can be instanced and bring all that stuff together. We also have actor merging as well, which is very simple to the HLOD, except instead of it automatically switching in and out the meshes, it actually creates just a set mesh that you can then use. And then finally, onto characters. Characters are often a massive bottleneck for production. They're usually very, very costly. They have a huge number of bones. They often have a huge number of weights and morph targets. And then you also have to consider the fact that you're animating this thing and it's having to move and do all of this stuff. So these are generally just very expensive and kind of always will be for the foreseeable future. But if we have a look at the kind of stuff that we do, so generally we've gotten pretty good at figuring out how to get multiple characters on screen all at once. So what I highly recommend, because there's nowhere near enough time for me to go through both this presentation and all the ones that I'm recommending in here, is that you take a look at some of our GDC content that we've got on how we optimized for Fortnite. Generally, with Fortnite, we have around 200 bones at LOD 0. We aggressively cull that from each LOD, and we have the proxy LOD tool that allows us to do that very quickly. Oh, thank you. We also have, again, the skeletal mesh reduction system. What we always recommend, and this doesn't just apply to characters, but applies just across the board, is to test early and to test often as much as you can. Always, always, always target the lowest quality platform that you're working on. And I mean quality in terms of performance, not in terms of the actual quality of the system itself. That means that if you think that you're going to be releasing on the Switch, you should make that your set platform, and you should build onto that as regularly as you possibly can. and just make sure that everything's working. Because if you can get it working on that, you can get it working on everything above. Even going from PlayStation 4 to the Xbox is a big difference, and there's a lot that you have to account for that. Pitfall 2, avoiding performance accountability. So we have a lot of studios, and we've got a lot of new studios, which is absolutely awesome, and they want to know what their art budget should be. And again, it's the same answer, which is how long is that piece of string? And generally, budgets are really good to have, but you do need to understand that you need to be a little bit flexible with those systems. What we highly recommend is avoiding the janitor model, which is basically just assigning one poor sap to be in charge of monitoring performance and making sure your assets are clean and good. What we highly recommend is making every single person responsible for the performance of the environment and performance for all the assets that they're doing. And while this can often create a little bit of back-end work, the end product will be that you have a large team who all have an understanding of the scale and the performance that the product needs to be going towards. And I also think that this is something that we just generally are moving towards across the board, right? One of the things that we've all noticed is that tools are becoming much more accessible, right? And as they become more accessible, that has an implication for artists who in the past have maybe not had to worry about that stuff because it's been too technical to understand, and that's had to be put onto another job. Now we have much more accessible tools, much more accessible ways of profiling. This is something that really we should all be taking on board and trying to learn and build on. So this is the way that we work at Epic. We try and make everyone responsible for performance and make sure that when they check out an asset or they check in an asset, they understand that that is something that they are responsible for. Now, obviously, there are automated test processes, but ideally, you want your artists, your designers, to be aware of what those systems are and how they can be affected before you start checking in your content. So we highly recommend that you make your artists aware of the performance and how they can isolate those problems and isolate those assets and get better content. So we have a range of tools that they can use and a range of commands that they can use. So the stat commands, again, they seem a bit techy, but they can be really, really useful in just getting a quick understanding of the kind of things you're building. So if you're creating an environment, just running through and doing stat GPU or stat game or stat lighting and just seeing what things are doing and what kind of costs you have is a really good idea. We also have show flags as well, along with view modes, which allow you to preview things in different orders. So if your scene is lighting up like a Christmas tree, when you go into your shader complexity or quad overdraw, you can have a fairly good understanding that that's probably a problem that you need to fix and work on. Again, all of this stuff is covered in our docs, so if you want to read more, you just need to search for it. Finally, we also have CPU and GPU profiling. This is a little bit more intense, but it's something that if you do find that as an artist you're really interested in it, it can be that extra step to help kind of get you a better understanding of the implications of the assets that you're producing, and as a designer and environment artist, give you a better idea of the assets that you're placing down and how things are positioned. Pitfall 3. Just going to have a quick drink. Using Blueprint unwisely. I feel really hypocritical talking about this one because I built a game made entirely in Blueprint, and the amount of stuff in the event tick would shock you. But yeah, I love Blueprint. It's absolutely incredible. It's awesome. Again, I think it's one of those tools that is just making game development more accessible to a wider group of people. rather than just programming. But there are implications to that, right? It's got this awesome user interface. It seems easy to use and to get set up. But the downside to that is that you're still not a programmer when you're doing it. And therefore, because you're not a programmer, you don't know the correct way of building assets, the correct way of building things, and what elements could be expensive or could be cheap. So first off, I don't want this to be a don't use blueprints talk, because blueprints are awesome. You shouldn't be afraid to use them. But there's lots of different use cases for when blueprints should and shouldn't be used. So a few listed here. Using it as a prototyping tool is absolutely incredible. It's got fast iteration time. You can really knock stuff together and just get something working very quickly. And we do see this happening at some studios where they're taking on designers who work solely in Blueprint to prototype new ideas, and then those ideas can then be better implemented later on with a programmer who can make it a bit more optimal. So creating simple event-driven logic. And again, if you're a programmer and you do want to expose some Blueprint usability, you can code things and expose that stuff in Blueprint so that your artists can use it. So rather than just letting your artists and designers run free on your project, you can basically go, here are the tools that I've created for you to do your job. I know that they run well and I know that they're performant. These are the ones that you should be using when you're trying to do these things. You can use it as a container as well, often a good idea, just as a kind of like a housing thing for information and for data. These generally, there's quite a lot of them in various games where they literally just hold data sets and assets, and that's it. They don't actually have any graph information in them whatsoever. And then the other really useful thing with blueprints is that it frees up time for the programmer, right? So that they can work on things that are more of a higher priority or of more complex, and it allows them to focus on those assets, which again is incredibly useful because you go from being a team of X many programmers and X many designers and artists to being, you know, kind of almost all programmers and able to produce and work on the game. So, programmers and Blueprint. Coders don't necessarily need to master Blueprint, but they should have a good understanding of the tools and the systems. Again, a part of the methodology at Epic is that while the artist and the designer should be taking responsibility for performance, it's also the programmer's responsibility to be educating and making sure that people are aware of that. So it's about kind of building a better community and just helping each other to understand how things need to be done. So obviously, some things are better. What we highly recommend is as soon as you're going into the event tick, again, as soon as you're going into the event tick, you should consider moving that to C++, just because, again, it's more performant. It's a quicker system to work with. So this kind of ties back to my previous statement. So programmers, well, non-programmers will almost always make bad decisions, right? And it's very similar if you've basically got a programmer who's just starting out, is, you know, basically the same as an artist or a designer who's using Blueprint because they're not programmers. So again, make sure that you're mentoring those people and helping them work through and learn efficient and proper ways to build things. So common Blueprint problems that we see a lot of the time are too many hard references. Now, when you make a hard reference inside Blueprint, it loads that reference, which means that you can have a single blueprint that could be potentially loading like 90% of your game in one go. That's not great. You don't want that. Too many components as well can be a problem. So when you're building your object and you're building it out of lots and lots of different elements, it's got to load all of that stuff in. So generally, you want to try and minimize that where you can. And then functionality as well. So you've always got to remember that Blueprint is slower than C++. So it's really important that when you start building things, if you find that you're building more and more content, it's worth moving that stuff over and not running it through that bottleneck in the first place. So again, just going to reiterate on the event tick. So general advice is to not use it at all. If you must, try and keep it minimal and keep an awareness of the kind of things that you're doing on there. One of the things that you can do is control whether your assets even tick at all. By default, they're all on. So you can go through and make sure that those are off if they're not actually needing to tick and don't need to do anything. Even an asset that has tick on, even if it's not connected to anything, it's still running through and checking, right? Which is still a cost that you need to be taking into account. So just go through and turn off all those assets that aren't using the tick. You can do this in code, or you can do it manually. You can do it inside the project settings, I believe, as well, to actually say, I just make sure it's off by default. What you can also do is you can change the tick frequency of each blueprint as well. So if you don't need it to tick every single tick, but you do need it to tick every single second or point of a second, then you can set it to do that, and it will only update and fire on those instances. But yeah, finally, there will always be instances where you probably will want to use it a little bit, but just keep in mind that it's expensive, and ideally, you do want to have that stuff transferred over. So, to summarize, the ideal blueprint is an extension of existing C++. All the heavy lifting is done in code. Most of the blueprints are purely just data only, so they're just holding data structures and information. And there's no graph functionality within that, and only overriding existing variables and asset references. So that's keeping your hard references minimized and as little as possible. And remember, this could be a lot of work for you, but your performance gains in the long run will make it worth it. Forgetting target platforms. So again, we touched on this earlier. The switch is an awesome, awesome piece of kit, but it can be tricky to develop for, as it's very similar to a mobile phone in terms of speed and in terms of performance. So when you're building for these kinds of things, you absolutely have to be making these considerations early on. It's a really good idea to do so. So if you think that you're doing it, you should consider yourself doing it. Get yourself on get yourself a dev kit, get yourself on the platform, and start working through those changes that you're going to need to make. So, as it's called, the lowest common denominator, so it's the weakest platform. You should always try and build for that, and you'll get good performance on the rest of your platforms just as standard. We always recommend to build once and deploy anywhere. So you create a single instance and you build across each of those things. And finally, just always, always, always be testing on those platforms. Make sure that you're running it in your test kits. Make sure you're pushing it to your test kits as well as your dev kits, and running it in different instances, making sure that those platforms are going to work and are continuing to work. Do not put off testing on your target platform. Again, make sure that you're doing this as often as you possibly can. I cannot stress this enough, which is why it's in this presentation like 3 or 4 times. So the more that you can get on there, the better. And just remember that there could be one thing that you do that is absolutely fine on one platform, but will cripple another platform. So it's important that you make sure you're going this. We also recommend that you don't build per platform content. There's a lot of switches that you can use that allow you to do this. So the shader graph has a quality switch that you can implement for any complex shaders that you just want to turn off and not have at certain quality levels. There's also platform checks in Blueprint so that you can get a platform reference. So for things like UI, it's really easy to just go get the platform and then switch out all of the UI with the particular elements that you're doing, rather than duplicating any UI elements that you have and having to recall them every single time you do it. We also have device profiles as well that we recommend using. These let you set specific parameters and settings for each platform that you're planning to deploy to. Common pitfalls 5. Improper granularity. So loading content via level streaming is expensive. If you've done any open world testing, you've probably found that there's a lot of stuff that you have to account for. And if you start packing all of your scenes in too densely, you'll end up with some hitching as you kind of go between levels. So while there is some async, there's no magic solution for this. Hopefully, as we progress our open world tools, we can start getting better systems. But at the moment, we recommend chopping your world up into smaller pieces. Again, this is always dependent based on the kind of game you're making. One of the key considerations is player speed. If you can move very quickly, you'll often find that you can beat the stream and just rocket off into outer space. So you've got to make sure that you're kind of taking the size of your worlds, the size of your chunks into account while you're building these platforms. Fighting the tech is another big one, especially for developers who are moving from Unreal and have been using a particular engine that they are very used to. One of the problems with this is that rather than trying to do it the way that it's been designed to do, they just try and do the exact same thing that they did with the other engine with Unreal. And that doesn't always work, or more precisely, it's just not a good way of working, right? There's lots of tricks and kind of ways of working that will optimize your work methodology. So you should try to adapt to those tools if you can. So things to know before you change the engine. So if you're planning on making any major changes to the engine to try and make it work in a way that you're doing, there is a large implication to doing that. So every change that you make to the base engine is going to make it harder for you to take on the new changes and the new builds that we push. And we push quite regularly at this point. And what can often happen is you pick a build, you stay on that build, and you stay on it for basically the entire of the game's production life cycle. And this isn't always the best way to work, because often you'll find that as new versions come out, more features are added, more changes are made, more and more of your team will be looking at those changes hungrily, going, oh, I really want that one. I really wish we had this. Oh, that auto-instancing is really, really useful. I wish we could have that. So every time you change, if you do decide to start changing, the more changes that you're making to your engine can give massive implications, to the point where it's taking you weeks and weeks to actually upgrade to the latest version of the engine. So remember as well, we almost never take on code changes from other people. If we do, they are very small, usually very minor, just kind of like plugins to the API. So once you build that system, that's yours to maintain. And that's going to be your responsibility to actually make sure it's updating and working with the newer versions of the engine. And remember, something that we recently did with the rendering refactor, we can change these systems at any time because Unreal is in a constant state of development and will always be developed and upgraded. So how to know when to make changes? If you're a licensee, you have access to UDN. And one of the things that we recommend a lot on UDN is you don't just have to post questions to a specific problem on there. You can post speculative questions to the UDN. Like, I'm thinking of building this new system. would this be a good idea? Are there any things that I need to consider with this? And this is often a really good way of starting a conversation between you and with Epic about the kind of tools that you're planning on building and whether you even need to build those tools. Because obviously in the past, we've had some developers who've worked on particular things only to have Unreal release a very similar workable thing on their side, and suddenly they're throwing away, kind of weeks of development because they don't need to do it anymore. So always reach out to us. We can talk you through your problem. Sometimes we can find a workaround for the particular problem that you have that doesn't involve an engine change. But just know that if our engineers advise that you don't do something, take that advice seriously, because it's very rare that we'd say that. Number 7, ignoring support structure. So I'm, as a developer relations technical artist, part of the support structure. So I'm here to help you with the projects that you're working on. Again, if you're a licensee, then you'll have access to UDN. It's very important to know the differences between UDN and AnswerHub because they look very, very similar. But UDN is a ticketed system with Epic staff who will be answering it, whereas AnswerHub is an open system where anyone can post answers to it. So while AnswerHub, you may get a quicker response just because there's a larger number of people who are out there, the quality of that response is not guaranteed to be 100% good. So again, if you're on UDN, you should be accessing it and you should be using it. And when you're asking questions, you should be asking early and often. So we're trying to get our response window down as much as possible. We know that some people have had some issues with UDN in the past. It is much, much better now. So if you have used UDN in the past, gotten frustrated with it, please come back. We miss you. Hopefully the new system will be better and you'll be more happy with it. One of the final things I want to add as well is that we get a lot of people who will post a question to UDN. It'll get answered, and then we'll find out weeks later that they weren't happy with the answer, right? That it didn't give them the information that they needed, or it didn't answer it in a meaningful way that they were happy with. If that's the case, just post that you need more, ask more specific questions. It is a conversation that you can have. It doesn't have to just be, here's my question and here is the answer, deal with it. You can push more and ask for more information. And finally, remember that speculative requests and speculative conversations as well about the kind of content and the kind of things that you're trying to build. So if you need something more than UDN, hello. We have, you should always post it onto UDN anyway, but you'll have a reference that you can use. Again, if you're a licensee, you'll have a manager, and you can escalate those things up so that we can get more people looking at it and get more people on it. The way that the UDN works is that you start off with a kind of base level of support, and that support gets escalated all the way up until you're basically talking to the person who wrote that system. So if those people can't answer your question, it will get kind of leveled up until they do. If you find that you really need support, we can always arrange for conference calls on Google Hangout or Skype or one of the other million systems that you can use for doing terrible online hangouts. And in some events, we can also arrange team visits where we can come to your studio, or you can do team visits to HQ, which over in Europe might be a little bit more of a long journey than if you were over in the US. And then when you're trying to figure out when you should be escalating these problems, so again, if it's time sensitive, if you've got a release window that you're rapidly coming up to and you're still struggling with some performance problems, that's a good time to reach out to us. Ideally, you've reached out to us earlier and we can have already helped you with these problems. But if not, That's a good way of doing it. Again, milestones as well is a big one. Often you can be dependent on having your milestone kind of targets met. So we're here to help make sure that you can get that. So make sure you know who your rep is and you know who that person is. If you're a licensee, again, it should be something that you're already aware of. And if you're not a licensee, consider becoming a licensee. Many of the worst cases we've seen from developers stem from not letting us help them when they could. A lot of the time, we find that developers don't want to talk about it. They want to figure out those problems for themselves. And this is a really admirable thing a lot of the time. And in many instances as well, I'm certainly this way, and I'm sure many of you are as well. Actually, finding the answer to the problem is the fun bit, right? That's the bit that's actually enjoyable and that you can get, you can get a lot out of. But what we do advise is if you are working to your time budget is you can just post it to UDN. That doesn't mean you have to stop working on the problem yourself. You can carry on working and building on it. So we recommend just getting more people involved, working on the system in parallel. And sometimes, even if we can't help you fix the problem exactly, we can help be a rubber duck and help get you through those problems. So remember, you're not an island. Stay in contact with us. We're here to help, and we will do everything we can. Thank you very much for listening, and enjoy the rest of Unreal Fest.